Okay, let's get started. So, we've got a lot of people. At the front. So, we've got a lot of people, so noise is gonna accumulate really fast. So try to be quiet. If I do make a mistake, or if you wanna like butt in whatever, feel free to like butt in whenever. Like I don't mind. I can explain it again, or if you want me to explain it again, right? So good. So as I already said, I'm gonna go over the 2024 paper, term 2, from last year. So we had 2 numerics questions last year, both worth 25 marks, and then we had the rest of it was the stats, right? It's very delayed, but so I'll be going over pretty much most of the questions that are given in your Mobius. Yeah. What?
Could you speak louder, please?
Can you come to the front? Okay, I'll see. If you can't hear me, just let me know. I'll try to speak louder, okay? Anyways, so this question, well, both of the numerics questions, they come from week 9/week 10. So this one covers week 9 content, which is to do with partial differential equations. And so does this one, but this one's a bit more specific, right? I'll explain both of them to the best of my abilities. But anyways, and the stats, there's like a bunch of shit that you can get overall. Like this one's to do with, I forgot what it's called, I'll be honest. But then at the end, it's just like a normal binomial distribution and normal distribution that we're going to cover, okay? So I've heard a lot of complaints about numerics being really cooked. But honestly, I'd say it's easier than stats because you can do it by hand. Whereas some of the stats stuff you're going to have to memorize. Like some of the code for MATLAB you're going to have to memorize and understand in order to actually answer your question. Whereas for numerics, it's just a bunch of formulas that you can just sub into the equation and you can figure it out from there. So let's get started with this question. So this is like an civil engineering based question using finite element analysis or whatever it's called, I don't know. But simply supported beam of length 4 meters, shown in the figure, is subjected to a linearly varying distributed load with maximum W0 to be 4.1 kilonewtons per meter. So they've given us a diagram, and I'll explain why this diagram is pretty useful in a bit. If you've done like Eng 2400, it will be good, because some of the questions to do with slopes as well as your shear, I think. We'll see, right? Anyways, so they've given us a deflection equation here. If you've done Eng 2400, you've probably seen something like this before. At the back, any questions? What's up? Yeah, shush. Anyways, they've also given us an EI value, and we're going to be using a combination of MATLAB as well as hand calcs to be doing this question. So last year when I did this question in the finals, I used purely MATLAB, and pretty much got it done within a few minutes. These MATLABs are just pretty goated. However, if you do it by hand, it will take a bit longer, which is completely fine, as long as you get it correct. That's like the end result. We just want to get it correct. So I'll try to explain all the content using like by hand calculations, all that stuff. So apply the finite difference method with h equals to 1 meter to find the values of the beam deflections at point x0, which is 0 meters, x1 being 1 meter, x2, x3, x4, so on and so forth. All right. However, first of all, they've given us this sub-question, which is to figure out some equations in terms of V1, V2, V3, V4. All right, and V0 as well, okay? So I want to take a seat. At the end of the question, by the way, they give you these set of formulas for you, okay? They don't expect you to memorize these. They can give it to you in the finals, all right? What we notice is that this is a second order differential equation, right? So it's differentiated twice, so f double dash, right? So out of the formulas that we have here, the only f double dash that we can use is here, the very bottom equation. So that's like a centered finite difference, right? And it's pretty much saying that if we have a function f of x, right, we can denote f of f double dash at xi, at a value of x equals to xi, using f of, what is it, xi plus 1. So you take one value after xi, you sub it into f, then you do minus 2 times f of xi plus f of xi minus 1, and then you divide all that by h squared. Okay. Another thing to notice is that they've given you an error estimate of OH squared. You can just ignore it for this question. Okay. Actually, finding the error OH squared is like beyond the scope of the course. Right, so you don't need to worry about it that much. Okay, so if I wanted to convert this into like what we have in the question, so in terms of v, right? So v, the partial differential of v with respect to x 2 times is going to be equal to v at xi plus 1 minus 2v at xi plus v xi minus 1 divided by h squared. Or you can like simply write it like this over here. Okay, I haven't done anything too crazy just yet. I've just rewritten the equation to make it look much nicer for us to answer the question. Does that make sense? Yeah? Andy, make sense? Yeah? Okay, cool. So what I'm going to do is I'm going to substitute this equation into our equation all the way up here, this one here. So instead of writing this, I'm going to have it as vi plus 1 minus 2vi plus vi minus 1 divided by h squared. Wait, let me bring my laptop closer. Okay. Does that part make sense? Yeah? In this question, they've given us h is equal to 1, but I've seen some people, they've got h equals to 2, h equals to 4, blah, blah, blah. But because h equals to 1 in this case, I'm just going to ignore it. I'm just going to keep it as this. Okay? Because h squared is just equal to 1. Yeah? Nothing too crazy just yet. So, what are we going to try to do now? I forgot. Okay, so we're going to have to figure out these equations now. Okay? I'm going to use a bit of MATLAB to help me out. So what I've done, so if you take a look here, I've written some key values. So EI, they've already said 10 to the power of 3. They've given us W to be 4.1 and L equals to 4. Right? That's straight from the beginning of the question here. Okay? So we've got W, L, and EI. So what I'm going to do, I'm going to write this equation on MATLAB. Okay? So, wrong subject, this one here. So I've made it F is equal to 1 over EI times minus W over 6L times X cubed plus WL over 6 times X. Okay, that's our deflection equation, or at least the second derivative with respect to X. And we've also got these values. So at X1, it's equal to 1. At X2, it's equal to 2. X3, it's equal to 3. X4, it's equal to 4. 4 meters, right, in meters. So what ends up happening is also another thing to note. So I've subbed it in, and I've taken X, instead of just taking X, I've taken it as Xi now. So I'm going to have everything in terms of I. So I equals to 1, I equals to 2, I equals to 3, I equals to 4. Right? That just shows the point of interest that I'm looking at, right? So for I equals to 1, when you sub in I equals to 1 here, you get 2, 1, and 0. Make sense? That's on the left-hand side of the equation. On the right-hand side of the equation, we have x1, which is equal to 1, and over here x1 is equal to 1. Okay? So on this right-hand side, we can actually find a value. Okay? We can actually find the value of the right-hand side. Okay? The left-hand side is still in terms of v. The right-hand side, we can actually find a value. So to find this right-hand side, you can just do it on your calculator, or you can do it on MATLAB. Okay? So I'm going to rub this out. So I've subbed in everything here 10 to the power of 3, 1, 1, and V0, in the question, they've already told us that V0 is equal to 0. Okay? So subbing in everything in, you end up getting minus 2V1 plus V2 is equal to 0.00256. Okay? When I put that on MATLAB, I get the same thing. So f of x1 is equal to 0.0026. MATLAB keeps it to 4 decimal places, so it should be 0.00256. If you have it like that, you won't get it wrong either. Okay? I'm pretty sure Elena's aware of MATLAB only giving the values to 4 decimal places. So I think in the finals they'll ask for it to 4 decimal places. Okay. Okay. So what do we learn from this? So if we go back to our equations up here, we have minus 2v1 plus v2. We know what the value of this is now. It's going to be 0.00256. Wait, let me use a different color. 0.00256. Okay. Any questions? Kaden, questions?
Can you repeat, like...
Everything?
Yeah. Wait, can you write down?
If you understand for one step, so for I equals to 1, it's just the same thing over and over again for I equals to 2, 3, 4.
Oh, okay.
Any questions?
Yeah, I think I get it.
Sorry?
What is the negative 2v1 plus v2 actually mean? Like how do you get it?
How do I get it? So I used the finite difference equation. So we can express our derivative, our partial differential equation, into in terms of v. We can make it in terms of v. So usually, if you want to solve it straight up, like if you want to solve this equation using integration, that would be an analytical solution, right? Which would be much harder to do. But in this course, we only do finite solutions. So we've expressed our derivative as a finite difference. So it's going to be in terms of v. So this is going to be v at x I plus 1. This is going to be v at x equals to I. This is going to be v at x I minus 1. Yeah? So what we can do now is we can sub in for I, so at different steps. So I equals to 1, I equals to 2, 3, 4, right? And what that does, it just changes these numbers into subscript. And those values we already have. So for example, I equals to 1, V2, we can, well, we don't know it yet, but we're going to figure it out. But we know what x1 is equal to. They've told us in the question, x1 is equal to 1 meters. Make sense? Any other questions?
Can you show us the MATLAB code?
So this is a...
Okay.
Okay? Hey, anything else?
Just see that.
Yeah?
Would you share this PDF and the MATLAB code to us?
Yeah, I can link it into the Google Drive at the end, yeah.
End of the session.
End of session, yeah. Okay, now I'm going to do the same thing for I equals to 2. So I'm going to use the same finite difference equation, so this one up here, but I'm going to sub in I equals to 2 now. So at I equals to 2, we get V3 minus V2, 2V2 plus V1. And on the left-hand side, instead of xi, we have x2, which is equal to 2. Question at the back? Question? Yeah.
With the top line that you kind of got the previous question, that up one.
This one?
Yeah, that one up. Why, where did the x's go?
No. So okay. So it's x1, but I've just subbed in for the value of x1. So they've given us the value for x1 over here. It's equal to 1 meter.
Right, so in the first question, the v of x plus 1, shouldn't that be 1 or 2?
Sorry? The value of v we don't know, but we know the value of x. So we're expressing these v terms.
Yeah, but let's see how it's I plus 1.
Yeah.
Yeah, where did the plus 1 go?
Oh no, so the I plus 1 becomes a 2. So that becomes v2 over here, so.
Ah, yes, sorry.
Yeah, so that's the left hand side of the equation. Right hand side of the equation is what they've given us at the top. Yeah? Make sense? Cool. Question?
In the formula, it's like f of x I plus 1. So
Yeah.
you just converted x into I.
No, so I'm saying that. So it's just going to be the deflection at that step 2, at I equals to 2. So it's pretty much saying deflection at x equals to 2, at x2. But to make it easier for ourselves to match what they've given us in the question, I've made it v2. Yeah. Okay. Cindy, question? Make sense? Okay. Moving on. So for So for I equals to 2, I'm going to do this exact same thing. Okay? So I've got v3 minus v2 plus v1. And on this right hand side, I'm going to sub in x2 is equal to 2. Okay? So x2 is equal to 2, which means we can actually find the value of this right hand side. And I'm going to do it using MATLAB again. So f of x2, you get 0.0041. Make sense? Yeah? Or you can just do it in your calculator by hand, which is what I did. So, who said that?
How do you put the function in MATLAB?
Up
You have to
here.
add those dots in front of like the times and all that.
These ones?
Yeah.
Oh
Talk
no,
about the function.
this function? Oh, are you talking about these dots?
Yeah, you have to put the dots before when you put the time sign and all that.
The dots is a time sign.
Full stop.
The full stop. Where's the mark? Where's the full stop?
Oh, never mind, it's different.
Oh, are you talking about? No. You don't need that.
Okay.
Yeah. I think that's in Maple, not in MATLAB.
No, it's in MATLAB.
It's in MATLAB as well. Okay. Yeah, I'll take a look later. Fuck, my iPad crashed. Okay.
He got a fetch.
I'm gonna move on to I4 now. So yeah. So for I equals to 3, sorry, not 4, but you get v4 minus 2v3 plus v2 on the left hand side. But in the question, they've given us that v4 is equal to 0. Oh, actually no, they have not given it to us. Sorry, but so you leave it as v4, right? And you do the same thing on MATLAB or in your calculator, and you end up getting your right hand side value being 0.0036. So that's at x3 is equal to 3 meters. Yeah, it's a bit of solid mechanics. If you understand solid mechanics, like I think it'll be a bit easier. If not, it's just a bunch of math. Okay. Anyways, I4, when you chuck in x4 into MATLAB, you get 0. So v4 is equal to 0. So when you sub this back in up here, this just becomes 0. Yeah? Surely that's not too hard to understand. Subbing it in, you get 0. Yeah? Cool. So therefore, for this one, you get minus 2v3 plus v2 is equal to 0.0036. So if you scroll back up to our third equation, this one. So I'm looking at this one now. So we just need to find the coefficient of V2, which is, in our case, V2 is just 1. Okay? So the coefficient is just 1. So this one over here is going to be 1, minus 2, 0, and then you have your numbers here as well that you calculated. Cool? Any questions? No? Okay.
Why is V4 equal to 0?
Why is V4 equal to 0? MATLAB says so.
What if mine is 0?
If it's not 0, then if it's not equal to 0, if it's not equal to 0, then you just don't put 0, right? And then what you do is you sub it back in up here and you take it to the other side.
Fair enough. Isn't it 0 because the deflection you differentiate once the slope you differentiate twice, that's the moment it has to be 0?
Yeah. So if you understand mechanics, then you'll know that it's going to be 0 here no matter what. The deflection at this point is going to be 0. So over here and over here. Kaden, that's another way to think about it. Because it's a support here, it's going to be 0. But that requires some prerequisite knowledge, which you're not always given. Alright? Okay. So, we now have our 4 equations in terms of V1, 2, 3, and 4. Not 4, V1, 2, and 3. So, to solve for these... Oh yeah, at the front. Are you guys listening? Yeah, I'd be quiet. So, we're going to solve a matrix. Okay? But, luckily, we have MATLAB. Okay? MATLAB makes it really easy. Alright? So, I pretty much just made a matrix. Anyone need me to explain the matrix? How I made it? Yes? Okay, I'll do it. So, what are the few equations that we have? We have minus 2v1 plus v2 plus 0v3 is equal to 0.00256. We have v1 minus 2v2 plus v3 is equal to 0.0041. We also have 0v1 plus v2 minus 2v3 is equal to 0.0036. Okay. So I've written out my 3 equations. So when you do some matrix multiplication, so you do matrix multiplied by a vector, this is what happens. So alright, take a look. So, the way we multiply these matrices together is by using dot product, okay? So we do, to find the first row of this one here, right, of our new matrix, we're going to do dot product of v1, v2 with a and b. So you get a v1 plus b v2, and you get a v3 plus b v4. Yeah, okay, I kind of skipped through that, but I'll explain it again. So, to find your first row in our new matrix or vector, we're going to take the first row and multiply it by our vector using dot product, okay? So, okay, wait, no, that's... Okay? So what I'm going to do is I'm going to do the opposite. So I'm going to go backwards. So I'm going to go from here to here. Yeah? So where our vector is going to be v1, v2, v3, and the coefficients of it are going to be our inputs in the matrix. Okay, so I'll explain it again. These are the values that we have, right? The equations that we have. If you take a look at the matrix, right? Someone's chatting. I don't know. It's pissing me off. Okay. Anyway,
It's just the tree equations that we found at the start.
yeah,
You have V1, V2, V3. When you multiply, it goes this way.
yeah. So look, you dot product this with this,
Yeah.
and you get your equation at I equals to 1. Then you do this one and this one, and you get your equation at I equals to 2 in terms of V. This is like some math 1A, 1B stuff, right? So if you didn't pay attention to matrices there, it won't make sense, right? Honestly, I didn't understand it until I did this course, because I skipped matrices, but you do this, dot product by this, right? And you get your equation down here,
Yeah.
yeah? So that's why I've written the zeros. Oh, fuck. That's why I've written the zeros.
So why are we constructing this matrix? Is it as?
Yeah, no, it's because you can't solve this. You can't solve these 3 equations that easily. It's solving 3 simultaneous equations together.
Oh, okay. So we're just using MATLAB, right?
Yeah, we're gonna use MATLAB. Yeah. So I'm gonna say that this over here is the matrix M. This is the vector B, and I'm gonna solve for V here. So if I scroll over, these are the values at the bottom are going to be the values for our deflections. Make sense? Jen, make sense? Are you sure? Yeah. Fuck. Anyone else? Does it make sense? No, I'm trolling. Low battery. What the fuck? Yeah.
If you scroll back past the yeah, do that.
Yeah.
How do you know which
So which one to use out of all of these?
Yeah.
So we're dealing with a second order differential equation, right? So d squared v over dx squared. So it's the second derivative. The only second derivative we have is this one. So that's going to be the one.
What about for other situations?
For other situations, I'll explain it. Okay? In the next part, we're going to find slope, which is the first derivative. So we have to pick from 1, 2, 3, 4, 5, 6. We have to pick the correct one.
Can you use like M/?
Yeah, you can use that as well. Yeah, you can use the other slash. So you get the same value. What the fuck is? Okay, sorry, my fault. You get the same values, right? Wait, where's Leo? It's not charging. My computer. Alright, quick intermission. So this is the one that I have, right? It's not working. So I'm gonna try to use this one. I don't know who this is, but I'm gonna try it.
I have one as well.
I think it's basically the HDMI cable. It's taking up too much power. Oh, let's go. Okay. Thank you.
I have mine at the top.
Yeah, if this doesn't work, I'll come to you. Okay, any other questions? Do you have a question?
There's a matrix in the middle where it has 1 to be 1.
Yeah, it does. Oh, no, 1 minus 2, 1.
Yeah, 1 minus 2.
Does mine not?
Your code has 0.
Oh, no wonder. Oh, those are the values. Yeah, so I typed in the matrix wrong into my MATLAB. No. So it should be. Okay. Yeah.
B is the 0.02641.
Sorry, these?
Yeah,
So
that's B, right?
Yeah. So that's the right hand side of our equation.
Yeah.
Because what happens is when you expand this out, right? Okay, so this is going to be the matrix that forms, and we know it's going to be equal to these. That's the first part of the question. Oh, that's like the first two parts of the question. I mistyped it. It should be 1. Okay. Yeah. So no, hold on. I'm trying to explain it. So the first row is if when you sub in 1. Why are you guys laughing? You guys don't understand it either. The second row is when we sub in 2. The third row is when we sub in 3.
Yeah, but when you sum towards 0.
Yeah, so we don't include it. Yeah. When you sub in 0, you get 0 as well. Yeah. When you sub in 0, you get 0 as well, so you don't include it.
And then the B thing is what?
So B is going to be the right hand side of our equation. So yeah, so you see all these values that I've got?
Yeah.
I've just put in a vector. Yeah. Alternatively, you could like do the matrix by hand and just waste 2 hours, or just use MATLAB, right? Okay. So the next part of the question. So we've done 18 marks. All of that was 18 marks.
18 marks. Halfway there. That's inflation.
So we've done this, we've done that. Okay. Shh. Okay, let's read the next part of the question. Calculate the slope of the beam theta, which is equal to delta v on delta x at points x0 and x2. Okay? So pretty much, one thing to note, delta v on delta x, that's a first derivative. So if it's a first derivative, we're going to have to use one of these 6 equations. Any idea which one to use? For our slope. So to substitute for delta v on delta x.
Yeah.
Which? This one?
Yeah.
How come?
Because it's the first equation.
So any of them except for the last one. So they're all first differentials, but which one do we use?
You've got to go, if the points are at the start, you've got to go forwards.
Yeah.
So like x0, you only have points ahead of it, so you have to use the forward.
Yeah.
And that has a low error.
Yeah.
So you
Yeah,
probably
okay.
use that.
So if you think about it,
So, what's the difference between backwards and forwards?
so yeah, I'll explain it right now. Wait, no, I'm not going to explain that actually. Yeah. You should watch the lectures for that one. I can't explain it that well. But I'm just going to tell you which one to use. Because, so he brings up a good point.
That's why. 'Cause
Right.
you can only,
Yeah?
it's backwards because you go backwards.
No, you, Liam, what were you saying?
Yeah, so you can't, there's no like x of negative 1, but then how do you know like which of the first?
That one has a lower error. The first one. I think if you use you can use either one, it doesn't really matter, it's justified. But that one has a lower error, so I'm going to use that one. So, I'm gonna use this. Okay? I'm gonna use the first one. Hey, if we use the center difference, so if you use the backwards one, if you try to find a value for x0, right, you end up getting x of -1, which doesn't exist. Right? Everyone understand? Rifa, what happens when you sub in I equals to 0 for this one?
You get 0?
No. What happens? Why can't we use it? Yeah. So we get x of -1, which we can't find. Okay? It doesn't exist. Because x0 is here, x -1. Yeah?
So it's because you can't use the other ones.
Yeah.
But why did you use the other ones, sorry?
I just explained for the centered one. For the centered one, sorry. Shh, shh. When you sub in I equals to 1, I equals to 0,
Yeah.
what happens to this x value?
Disappears. Oh, it's negative.
Yeah. So you get x of minus 1,
Yes.
which doesn't exist.
Why does that? Ah.
Because yeah, x0 is over here, x minus 1.
Because you don't get x1.
Yeah.
So if you do that for all of them, the only one that works is
Yeah, but we're not going to do it for all of them, we're just going to do it for one of them.
No, I'm saying that's the only one you can do.
Oh yeah, that's the only one we can use, yeah. So, here it is. And I've already explained it. We're going to use this one. And I'm going to ignore the, yeah?
Sorry, why are we not using the second forward one, even though it's like same?
Because the error on the first one's lower.
First one, what?
The error, so this one,
Right.
is lower.
Okay.
OH and then
So
OH
you're gonna
squared.
use the one with the lower error.
I think you can use the other one. I don't think it matters, but you can, yeah, pick the one with the lower error.
What's OH?
That's the error.
Who's the one with the lower error? Yeah.
Oh, but the second one has lower, man.
This is lower error.
Yeah.
Why is that no error?
The error is like it's like when you approximate stuff with a line or with a curve. The curve's a bit better than the line.
Yeah, it's fine. But pretty much, you can use either one. Doesn't really matter. Utsa, shut up!
Sorry.
Alright. Watch now. Alright, so other one. I used the first one and I got it right. It doesn't really matter. Alright. I think it's right. Oh yeah, I subbed in the values wrong. So this should be 0.0049. And this one should be 54 and then 72. What happens when you do that? I don't know. 0.0072 minus 0.0018. Okay, yeah, that's your answers. Okay? Okay. For slope. Yeah. So you're just using a different finite equation. Or finite difference equation. Okay? There's actually one more part of the question. The very last part. So, for this question, how can the accuracy of the numerical solution be improved? So it's going to be either include boundary conditions, doesn't really do shit, right? Boundary conditions doesn't really matter, right? You're going to get the same answer. Reducing H does help. Using lunch cutter, bullshit, right? Anyways, I'll explain why 2 is correct as well. I'm going to go back to like first principles of differentiation from like 2-unit math. I'll try my best. Let's say we have a curve like this, f of x. Yeah, I lucky forgot. But then, you want to try explain it?
No.
Yeah. Okay. Cool. I'm explaining why reducing h gives us a more accurate answer. No, you don't have to, but I'm trying to help you. Right? You know what? Sack. Yeah. Okay, I'm going to move on to the next question, which is to do with week 10 content. Alright, so we're looking at heat conduction equations, right, or heat equations, Laplace equations, all that stuff. Alright, so the heat conduction equation for a thin, long rod is given by this. They've given us some initial conditions as well. For the temperature, temperature is given by T of xt, so it's a two-variable equation, multivariable equation. Alright. Okay, so the temperature at each end, so if you remember from the lectures, this is what the diagram looks like. This is what the thin rod looks like, right? Where this is L. Right? So, this is going to be one end of the rod. This is going to be the other end. Oh, okay. This is going to be the other end of the rod. At both ends, there are some temperatures that he gives to us, right? So, at x equals to 0, so this is going to be x equals to 0, this is going to be x equals to L. So x, we're moving across right. They've told us at x equals to 0, it's 35 degrees. 35 degrees. At x equals to L, it's 75 degrees. Okay? At any time t, at time t equals to 0, the temperature is distributed along the rod according to this function. Okay? So that's at just time t equals to 0. So this question, there's like temperature that changes along with distance as well as time. That's why it's a multivariable equation. So as time goes on, it might get cooler, and as it moves along the rod, the temperature also differs. So that's two things that we have to account for when we're constructing this table. Okay? So, let's take a look. Apply the explicit finite difference method with delta x being that, delta t equals to that, and just fill in the blank spaces. So the blank spaces stand for what the temperature is at a certain time and at a certain distance away from the origin. Okay? Any questions about that? Okay, cool. So the explicit formula, they've given it to us here. Right, this is week 10 stuff. So I'm going to pull up my notes really quickly. So this is something that really helped me a lot last year. So when we were looking at something like this, so temperature, the number at the top, so our superscript stands for time, and our subscript stands for our position. Okay? So if our I changes, that means we're moving along the rod. If our L changes, that means our time's increasing or time's changing. Right? So T00 stands for temperature at the boundary, so at initial time as well. So at L equals to 0 and I equals to 0. Alright. So in this case, it's going to be here, the coordinate is 0, 0. So that's going to be our temperature when time equals to 0 and we're at the position x equals to 0. Okay. Any idea what that value is? What is it? Oh, in this question, in your question it might be what, 25? 45, and this question is 35.
Oh, yeah.
Yeah? So the green ticks that I made here are the values we can tell straight away. You don't even need MATLAB, you don't even need math to even plug them in, right? You only need like MATLAB or some sort of like math to only figure out these four, okay? So everything else we can actually figure out. Okay, how about at t equals to 0 and at the position of I? What do we think the temperature is going to be? At time equals to 0. So, okay, well, hold on one second. I'm asking you, what is the temperature when we're at the position x equals to 0.5 centimeters and at a time of t equals to 0?
It would be u plus 20.
No.
0 would be 55.
55? Where'd you get 55 from?
Oh no, yours is.
Oh, mine's 35. So,
Oh, yours is pi minus 30.
oh wait, sorry, this should be 35. Sorry, my fault. So what should this be? Why would it be 55?
Is it just the function?
Why would it not be?
Oh, have you exactly used the function?
Ugh. Oh, yeah, my fault. It is 55. Sorry, it is 55. Yeah, you'd have to use the function. Sorry, I was thinking about it the wrong way. So, yeah, it would be 55 because we know the time at t equals to 0. So, everything in the first row follows that formula over there. Okay? Everything in the first row yeah? That's only in the first row. When it gets to other rows, we can't tell. Okay? We're gonna have to do some math. How about in the first column? Do we know all the values in the first column?
Sorry, how did you get the 55? Do you sub the x equal to 0.5 to the formula given?
Yeah, and you'd have to do it in radians as well.
Ah.
Yeah. So if you use radians, then it would be 55. Okay, how about these two numbers? Both of them? Or just one of them? Come on. You're halfway there. Yes or no? Both of them going to be 35?
Yeah.
Yeah.
Why? Because x equals 0.
Exactly, yeah.
What do the rows affect?
What are the rows? What do you mean?
Rows. Like what's 0, 0.1, 0.2, the seconds? You sub that in anywhere or not? Yeah.
We will sub it in at one point, and I'll show you. Right now, I'm not doing any math. I'm just filling out the table with the information they've provided.
Yeah.
Okay, so I'm not using the explicit formula just yet. Okay, how about this last row down here? What? 75. Perfect. So because it's the value at x equals to L at any time. So that's using this one here. So x equals to L at any time t. Yeah? That's how we go about doing these kind of questions. There's actually one more. I'll just fill it out. I'm going to use my brain. 69.54. I'm going to use my head. 64. Fuck. Okay? Okay, so when it comes to these ones now, we're going to have to use the explicit formula. Okay? So the explicit formula is as follows. So first of all, you have to find lambda, right, which is a parameter that we have to find. And you end up getting 0.236. Depending on the question, you might get something different, right? So this is the formula that we're going to use. And we're going to find the value. Oh, sorry. I was meant to fill this out. But we're trying to find the values at node 11, 12, 21, and 22. So these are going to be the subscript and superscript of our equation on the left, or our t value on the left here. So if you want to find t11, right, that means our L is going to be equal to 0 and I is going to be equal to 1. So I'm going to sub this in. I'm going to say t of 0, 1 plus 0.236 of t 0, 2 minus 2t of 1, 0 plus t of 0, 0. Yeah?
Why did that 0.236?
Where'd it come from?
Oh, yeah, that's right.
Yeah, it's right here, yeah? That's our lambda parameter that we have to account for. So if you go up, in the equation they give us this lambda equation. Alright? Okay, so. And in fact, we already know all these values as well. So you just have to sub it in. So at 0, 1, 0, 1, it's going to be 55. Uh, 0, 2, it's going to be 69.64. This one is 55, and this one is 35. Right? You're going to sub in your values, and you get some. You can do it in MATLAB, you can do it wherever. You get 53.735. C. Okay. Any questions about how I use the explicit formula? Yeah?
Sorry, so the t value you got from there is from the table, right?
These ones over here?
Yeah.
Yeah, those ones I took from the table. This is what we're trying to find.
Are they from the same row? Or like just
They are from the same row, yeah. So these are all from the row T0, this one here. No problems. So, does anyone need me to explain how I got these subscripts and superscripts?
Yes.
Why didn't you say that? You should. Nah, don't worry about it. I'm not gonna explain it. No, I'm trying. So pretty much, what are we trying to find? Which node are we trying to find? 1, 1. Okay. So this thing over here is t of 1, 1. True? Yeah. So, cool. So you understand that part. That's good. So I'll explain it again down here. T of 1, 1 is equal to. So I'm gonna go back up to our explicit formula. You want our left-hand side to be t11. So I want this to be 1, I want this to be 1. So to make this 1, what's going to be the value of L? 0. This, what's the value of I? 1. Right? So I'm going to replicate that over the right-hand side as well. So I'm going to let L be 0 here and I equal to 1. I'm going to let L be 0, L be 0, L be 0. And I'm going to let all these i's equal to 1. Cool? And so that's where I get these subscripts from, and superscripts. And all of those are from the table. Make sense? Anyone else confused about how I got that equation?
No.
No? Make sense? Are you sure? Do you want to come to the board and do the next one? David, right? Do you want to do the next one? He's got it covered? You want to come to the board? How about James? You want to come to the board? Oh yeah. Do you want to do it here though?
Yeah, I know you did though, yeah.
Do you want to do the next one? What's the next node? 1, 2. Alright, who wants to do it? Andy, you? No. Kaden, you want to do it? So you're trying to find T. No. Alright, I'm picking my next target. Okay? So I want you to do the same thing. So use this equation.
Yeah.
This one. And try to find just the equation of T12. Thank you. Who's next? Sandy? Oh. Jared? Jared? You got it. Sam? Andy, you want to do it? Come on.
Kaden's not done yet though. No, I'm done. Crazy. Like what?
Yes,
Except for my
that's correct, yeah.
I had like T0.5. We still apply it.
Oh, okay. So you're talking about these are what? The value of x and
Yes, yeah.
No, but these are just steps. This is just a node.
Oh, and then each step is that.
Yeah. So this is t at x3, which is equal to what? 1.5.
Oh, okay.
Okay. Alright, Andy, come on. Alright, we don't have all day. I still got stats to cover. No, 1, 3 is already done. I want you to do it. And I also need someone to do it.
Is that the first one?
Huh?
So it's 2, 1 with
Flora, you want to try the next one? Rifa?
Rifa should do. No, you should do.
Come up, Rifa.
Very satisfying. Come on, Rifa. Come on, you should do it.
Who wants to do the last one? Do you want to do it? Come on.
This would be 2.
I think you can do it.
Wait, it's not that hard. It's just,
No. Do you want to come?
Oh, you should
it's just
go.
look, in the corners there. Just
How to
don't
get
get
there.
up.
You ain't said so, you should go.
This is just literally.
If you really think about it, it's nothing.
One more. James. David? What's your name? I forgot.
If you want the answer on the board, which what you mean what to do, I'll do it.
I'll do the last one. So this is our time node. This is our distance. Yeah. No, it's not.
So how do you know what to make what?
What do you mean? Do you want to try this one?
I don't know what to make what.
Do you want to write out the equation for this?
I can give it a go.
Give it a go.
Right? I don't know what's going on there.
Now you were here for that last part. Believe in yourself. So we're using the explicit equation in the middle to write out the right hand side. So they write out the right hand side here. So I've already given you
That's time, right?
Yeah.
Yeah, so just.
Yeah, perfect. So these are what we have, okay? When you sub it in, you can do it on MATLAB. I'm gonna do it manually. I'll be honest, seems okay. I'll do the last two. First one, don't worry. Fuck.
Yes.
Can someone do it for me? Okay.
But just give us the values and we'll put it in.
Okay. So, I need you guys to help. Can you guys figure out these values? Figure out the values.
It's 236 for lambda, right?
0.236. What do you got?
$67.45.
This one?
1, 2, yeah.
I'm getting 72.17.
Oh, I might have put it in wrong.
Hold on.
This is basically actually the same as
What is for one?
So I use so I is the vertical
Yeah.
and J is the
So,
so I is the first one, second one. So we go to the second one, third one.
Well, you can do
Bro, I'm already doing the way.
Just
I'm gonna get the project.
That's the small point.
Where'd you get the 5374?
I figured it out.
I just paid for something.
Oh, there's another one there.
You have takes so much.
This one was like confusing me.
How will you do that? Just the formula. Just put in all the values in the formula.
Yeah, like we have 4 values, right? And the 3 equals exactly 4 values. So you don't need to do the equals. Just look for those 4.
Oh, so the thing is, you first we need to find out
Okay.
those 4 values.
So that's the table complete.
For T2.
Any questions?
Like, why is it so like, why is T? You know, why is like T squared?
Questions? Make sense? In the middle. Questions? Question? No? No? Jared? Make sense?
No, it makes sense.
Somewhat? Jared? Somewhat? Yeah. Okay. Anyways, the next part of the question is given. We have to find the thermal energy, which is given by ET. So this question kind of messed up a lot of people last year because of the notation. No. What? What do you mean? No. Anyways, this is the thermal energy at the time T equals to T squared. But it's meant to be T equals to T2. So T equals to 0.2. It's not T squared. It's at 0.2, T2, which is 0.2. So what a lot of people did, they tried to solve the integral by subbing in T equals to T squared over here. Which honestly, don't do that. Instead, what I'm going to do, I'm going to explain how to, I'm going to explain the understanding behind this integral, just a little bit, okay? So, here it is.
Sorry, where does that 0.2 come from?
Yeah, sure. T2, it's in the table here.
No worries, thanks. That's what I need to do.
Yeah.
I like using the L thing at the top where it's just.
L.
But it looks like it's squared. No, it's right.
That's alright. Okay.
They kind of kept the times at the top the same as the big T's.
Yeah.
It
Okay.
just looks weird.
It does look weird. Okay. Anyways, so this is Simpson's rule, right? If you're not familiar with it, don't worry. They give it to you in the paper, right? They give you all the key formulas that you need in the paper, right? Or at least most of them. If they might give you some extra, some stuff that you might not need. In this question, they only give you one, so you need to use it. So, but the integral, the energy, it's given by the integral of T squared. Shh. Wait. It's given by the integral of T squared, but we only have T. So how the hell do we find T squared, right? How do you even find this integral? There's no equation, there's no nothing, right? Using finite analysis, right? It's actually really easy. So imagine we have a graph, some random graph, ambiguous graph, y equals to f of x, right? And we've got our steps x0, x1, x2, x3, with a and b being the initial and final point, right? So we know the height of this is just going to be the value of the function at that x value. So f of x0, this is going to be f of x1, this is going to be f of x2, and this is just f of x3. Everyone get that? Yeah? It's just, math. Yeah? But if okay, so the t squared in the integral means we have to add up the squares of all the temperatures. So if I square the function,
So
right?
that's actually a square.
Yeah, inside the thing is a square. Yeah, the t squared is a square. They even say in the question they say,
Square of the temperature.
calculated by integrating the square of the temperatures. Right? So if I draw the graph, so y squared or f of x squared, right? All the y values will be squared as well. So this one over here that's going to be f of x0 all squared. Okay? And what we need to do is we have to sum up these heights. We have to sum up these heights. So if I go back to this formula, these ones are going to be the square of the temperatures. So this is going to be T 0, 3 squared, something like that. So we're trying to take it at, no, sorry, it should be at time t equals to t2. So it should be t2 of 0 all squared. Not 3, 2. Okay. And we just sum it up, divide by 8, and this becomes L minus 0. Okay, so here it is. So the 2's, as I said earlier, the superscript just means at what time value, what time step. They're all going to be at t2. So these ones over here, this time steps, they've already told us in the question, it's going to be t equals to 0.2 seconds. Jen, you look confused. Make sense?
So if it was like t equals 0.1, you use the little row instead of the number row, right?
Yeah.
Yes.
So yeah, so pretty much we have to use, in this question, we have to use the third row.
Yeah.
But if they said t equals to t1, which is 0.1 seconds, we're going to be using the second row. So these are the temperatures at t equals to t2. We're going to square them and add them together. Alright, so this one over here, t20, this is going to be 35 squared plus 3 times 52.55 squared plus node 22, 66 squared plus, what's the last value? 75. 75 squared. And we know that L is just equal to 1.5 and the initial value is just 0. Okay. So you put this in your calculator. There's a huge number. 2643.99. What's the units? What? Oh, yeah, I don't know the units, I'll be honest. But yeah, that's the number we get. It's a pretty big number.
Wait, so I is the integral?
Yeah, I is the integral. And the integral, we're going to use Simpson's rule to find it. Make sense? Questions?
So, are you only squaring it because it says t equals to t squared?
No, I'm squaring it because in the integral, so this t squared part, that's not y.
Yeah.
This just means it's t equals to 0.2. So what we have up here. The t squared comes from this one here.
Oh, okay.
Yeah, so in the question they actually give us the function txt all squared.
Yeah.
That's why it's squared. And it's from 0 to L, where L is just the length of B of the rod, which is 1.5. Make sense? Okay. Okay, so that's pretty much all of numerics, week 9 and 10. Yeah? Not all of numerics, just week 9 and 10, sorry. But that's what we got in our finals last year. You guys can probably expect like a Runge cutter. I don't know, don't take it from me. I just hated Runge cutter last year. I prayed it didn't come up. And it didn't. What else is there? Newton Raphson. So I've got a MATLAB compiled. So this stuff, it just goes through all the weeks. And it goes through all the MATLAB code. Alright? So if you don't want to do it by hand, if you want to save time, memorize the MATLAB code. Right? So I memorized the MATLAB code before I went in for both numerics and stats. Alright?
I'm putting in
Yeah, put in the Google Drive. Yeah. So this stuff. Alright. I just don't have anything for the last 3 weeks. Alright. Yeah.
Yo, how can I access that?
I'm gonna put in the drive.
How do I even get access to it?
I'll give you the drive. Don't worry. Okay. Okay, let's move on. We don't have much time, so we're gonna do some stats. Okay? Who likes stats more than numerics? No one likes stats? You're lying to yourself. Do you actually like stats? Or are you lying?
No, I'm not lying.
Fuck, right, okay. That's weird, I'll be honest. I don't like stats.
Well, no, I don't actually like stats, but I like stats more than numerics.
Oh, okay, true. No, I still like numerics better. I don't know, it was a bit easier to understand.
I would like numerics more if we were allowed to bring in code.
Oh, you're not allowed to bring in code. Do they give you the MATLAB booklet?
Yeah.
They do, right?
Yeah.
In the finals? You're also allowed all the lecture notes?
No lecture.
No lecture
Not
notes?
for numerics.
Numerics, they say it's just the formulas.
Oh yeah, numerics makes sense. They give you the formula anyways. Yeah, that's better in my opinion because stats is a lot of theory. Right? Oh yeah, by the way, so I went through a recap workshop last year as well. And that was going through a different paper, which I've also got in my Google Drive. So I'll post this and you guys can have access to it as well. So I think you guys might have this on Mobius? Yeah?
Yes, the
So this stuff. And there's also a video recording of it as well. Alright, so I go through the numerics and I also go through the stats. There's more variety of stats in this one compared to what I'm going to go through today. Alright, today I'm just going to go through 2 small stats questions, mainly just MATLAB coding. Okay, this stuff used a bit more brain. Back then, I actually understood 2002 more. Now, not really, right? But there's a bit more. If you watch the video, it'll be a bit better.
there's heaps of like text boxes in some of them as well.
Textbooks?
Text boxes.
Oh, text box. Oh yeah.
For the stats, right?
No.
At least the ones, some of the ones on this, yeah.
I don't remember. I'll be honest. But
Can I just ask like one question about like it's not related to that?
okay, yeah. Real quick. Okay, I'll give everyone a 1 minute break. 1 minute break.
Because like I need to go.
Yeah.
For this,
Oh yeah, this question I've actually gone through.
how do you actually calculate the value? Because timesing mu by 20 doesn't work. I don't think.
Nah, it shouldn't work.
Yeah.
For part A.
Yeah. Part A I got that right, but for part B I don't know how to get that one.
Gotcha. So this is my working out. So there's a bit of math. Don't worry about that stuff. So don't worry about this.
Wait, I'll just take a photo.
Yeah, sure. What I'll do you want access to your drive right now?
Yeah, sure.
Oh, actually, if you search up Sigma lectures on Google, and you'll come up as a first link.
Yep.
And if you scroll down a little, you will see CVEN 2002 isn't there. What the fuck? Alright, what I'll do, I'll make a QR code for you real quick.
Wait, do you also have working for question 5? I'm also confused about like how to calculate the power. I think how do you calculate power of like hypothesis test?
I don't quite remember. No, I don't quite remember.
Okay.
No, I think it should be in the lecture somewhere. I'm pretty sure somewhere in the lectures. On Mobius, there is something there.
Okay. Wait, can you quickly explain like the logic behind that previous question?
Which one?
The exponential one.
exponential.
Yeah. Like this one.
Oh yeah.
Yeah.
So, alright. So here's mine. So what I've done to make it a bit easier for myself, they'll give you a sample size of 20.
Yeah.
So instead of writing an x1, x2 all the way to 20, I've just made it to t. Alright. That way I can say that in this case you want to be t is greater than 124.
Yeah.
What that helps us do is it helps us find the expected value for this probability. Yeah, take care, bro. I'll send you the recording.
Yes, sir.
And then you can also find the variance as well. Because this is what, exponential distribution. Is this exponential distribution? Yeah, this one is. They have the certain formulas that you can use. So 16 times mu and 16 mu squared.
Wait, why wouldn't this be 16 squared?
All these Friday.
Why would it be?
Because
No, because if you think about it, you can split up the variances like this. There's
Oh, yeah,
And there's 16 pairs of them, or 16.
Okay, yeah.
In this your case, it'll be 20 pairs. Right? And from there, you can get your standard distribution, and then you use your non-standard.
For this question, I used like expected value of 80, which is 4 times 20, which is what like it gives. But then the answer is not correct. Like I searched it up on ChatGPT and it says to use some like gamma like Erlang.
Yes, so it should be 20 times mu. What's your mu?
Mu is 4.
So it should be 80.
Yeah, but I used that the first time I did, and it wasn't correct.
Oh, did you do this correct as well? Because if you did one of them wrong, then it's going to affect your final answer.
Wait, we need to input variance.
Huh?
We need to input variance.
You need to input standard deviation. And that's a function of variance.
Oh wait, this is a standard deviation.
Yeah, you have to put in standard deviation.
Oh, okay.
So that's affected by your. Alright, so if you want to scan this is your QR code for the let me know if it works.
Wait, I was using the the exponential
Yeah.
the exponential CDF, EXP CDFs again, and then with mu is 80 and that didn't work. Okay, cool. I got it.
Make sure you save it, so just in case.
Yeah.
The recording will be posted up on our YouTube, Yunus W Self-Sock.
Okay.
We'll find it there.
Thank you.
No problems.
Go borrow.
Okay.
Yes, sorry, can you go back to the QR code?
Oh yeah, sure. I haven't uploaded anything just yet.
Oh, okay.
But yeah.
Are you going to upload this on YouTube?
Recording will be on YouTube.
Oh, I got this photo.
What website?
YouTube. It will be on Yunus W Self-Sock. Self-Sock Yunus W YouTube. I'll show you.
No, this is going moving into
So we posted here. Alrighty, stats. Let's get started. If you are leaving, leave quietly.
I'm going to start today.
What's going on? Thank you. Wait, at the back. Shh. Listen up. Okay. So I'm gonna try to go through 2 stats questions. One of them I'm a bit not that confident about. The other one I'm pretty confident about. Okay. Google AI said I was correct. So let's try it. So suppose that 44% of the population favors a certain candidate in an upcoming election. In one study, a random sample size of 25 is chosen.
Sorry, which year is this?
2024. It's the next question. Yeah, it should be that. This is a very final question.
The second question.
Yeah, second step. So, determine the expected value and standard deviation of the number of members that favors the candidates from the sample. So, what kind of distribution do we have? Any ideas what kind of distribution we have?
225.
225. 224. That's not a distribution type.
Binomial?
Yeah, binomial. How come?
Because you got to choose actually like out of the 40 or something.
Yeah.
Could you, there's two options.
Yeah, there's two options, exactly. It's either favorable or not favorable. So we've got two options. Therefore, it's going to be a binomial distribution. So, binomial distribution has a few special formulas for expected value and standard deviation. So, expected value, which is given by mu, is given by NP, where N is our sample size, P is our probability that it's favorable. Standard deviation is equal to the square root of N, P, 1 minus P. Okay? Exponential formulas and the other ones, they've got some different formulas, right? Which you can find in your lecture notes. Okay? And they're also in my notes somewhere. So exponential distribution has mu and mu squared. Uniform distribution is a bunch of bullshit. Bernoulli distribution and binomial distribution, here it is. In this case, P is equal to pi. Alright, same shit. Okay, cool. So what you're going to do is just sub the numbers in and you get your values. Make sense? Okay. Any questions? No? David, why are you laughing? Make sense?
Yes. This is the high school extension one.
High school extension 1? True. Yeah.
So do you want to do the question?
Yeah, do you want to do the question?
I have to do that one. Let's go to this. I want to talk about
I think you can do the next. Do you want to come up and do the next?
it. Yeah, all good.
Oh, good. Okay. So, calculate the exact probability that more than half of the members of the sample favor the candidates. So, pretty much what we're trying to find is the probability that more than half of the members, so vote for the sample. However, we run into a bit of a problem. We can't have 0.5 of a person voting. Alright? So, round up, perfect. Because it's greater than 12.5, so we can round it up to 13.
Don't you always round up, even if it's like 12.1?
Yeah. Well, if it's greater than. If it's less than, then you need 12. Yeah. This you can plug straight into, what's it called? MATLAB. Okay? So you're going to use a bino CDF function. If you want to do it by hand, it'll take a while because it's got like that huge sum formula. Instead, you can use bino CDF. Okay? Any questions about the code? No. So just MATLAB that shit and you get 0.1569. Yeah. The next part of the question is a bit more tricky, right? They're asking for an approximation of the probability using the central limit theorem. So the central limit theorem is like this thing. Is that it? I think that's it. All right. We're trying to find the probability of x being greater than this. Okay? So we know what mu is. That's just the expected value, which is given by 11. And standard deviation, we found it earlier as well. We found it to be 2.482. Okay? And in this case, x is going to be 12.5. Alright, when you plug that into your calculator,
Is that meant to be over square root n?
Is it? I don't think so. Central limit theorem. Oh, I see what you mean. Probably. What a riveting question. I think it might be. I don't know about binomial distribution. No, binomial distribution. I thought it was different. Yeah, I have to have a check. So it's either going to be this one, or you use x minus mu over square root of n, where n is our sample size. What does the question say? Based on the central limit theorem. Oh yeah, I'm gonna have to double check, but yeah, you can use either one of the formulas. But the main thing is, I just want to show you guys the MATLAB code. In this case, we're not going to use bino CDF. Okay, when we're like using the central limit theorem, we're switching to a normal distribution. All right. So instead of using bino CDF, we're going to use norm CDF. Okay. So on MATLAB, it's going to be 1 minus norm CDF of whatever value you get inside. Okay. Oh shit. So if you go here it is. So our central limit theorem, whatever it is, it's normally distributed around the center of 0 with a standard deviation of 1. Okay? Okay, I'm gonna have to double check that one, David. But okay. Anyways, part D. So they've given us a new sample, x2, for a variable of x2, and a new sample of 127 people. We're asked to find the expected value of x1 plus x2, and we're also asked to find the variance. So, they've told us that the two random samples are independent of each other. Okay, that only affects the variance. So if you think about the expected value, this is going to be equal to e of x1 plus e of x2. Right, this is the basic formula. That's true for like any distribution. But for variance, this will only equal to variance of x1. So this is, you guys can't see that, but this is only true when x1 and x2 are independently. Okay, if they're not independent of each other, there's like some sort of covariance bullshit from like week 2. But in this case, they've told us it's independent, thankfully. So we're going to use that formula. Okay, so I'm going to scroll down. Here are your values. Oh yeah, also variance. The formula for variance in a binomial distribution variance okay. So here I have it. These are my solutions. Any questions? Can it make sense? Are you doing the paper as well at the same time?
Yeah, but with my
Does it work? Did you try the this thing over here on the left?
yeah.
Which one works? This one or this one?
Wait. Let me try for your values.
as in like which formula works. So one of them has a square root n, the other one doesn't.
That's my.
Which way is correct?
I don't know.
Oh wait, so you're I thought you had maybe so you were checking.
I do have it open, but it doesn't have to have it.
It doesn't have what I do.
Yeah, just for that cable.
Okay. Okay, I'll just say use this one.
Oh, maybe you can just sum the code.
Yeah.
You just have the code for people can check out.
Go pick up, okay? Use the square root of n. So in my solutions, I don't know, Google AI said not to use square root of n.
What?
Google AI.
But you got it right.
But I think having it without the square root is a higher number, which is better.
You know what? Nah, I'm gonna stick with mine on. Okay? I'm gonna stick with it. And also, it's meant to be 1 minus norm C, guys. Right. Okay. Oh, fuck. Next question. So the next question is asking us, compute the exact probability of here, this one, right? This one, you're gonna have to do a bit of algebra and a bit of like manipulation. So I'll show you what I've done. So this over here, yeah, one sec. I'm getting monster everywhere. So because it's an absolute value, there's gonna be two legs to it. One's gonna be positive, one's gonna be negative. All right? So eventually, when you simplify it, you get this. Okay? Anyways, this thing over here, no, sorry, is here. Alright, and this one is here. So, yeah?
I think your first one is correct.
Yeah?
Because you only would use the second one with the square root n, so you don't know what the standard deviation is. So it gives you the standard deviation. So if you want to calculate what you have.
Okay, yeah. Also, one more thing I forgot to mention is that I applied a continuity correction. So, I think that's why. It might be because I applied a continuity correction. So instead of it taking greater than 13, I've minus 0.5. Okay? I've used that. Okay, anyways. There's really not much to explain here. It's just a bit of algebra and then using MATLAB. Okay? Any questions about this last one? Okay? This one I actually needed help with. I didn't know how to do it.
Hey, thanks, Matt.
No worries.
Also, thanks for the files, bro.
Yeah, no. What files? Which one?
But you want me to
Okay, anyways. So, there's actually one more stats question that is I fucking hated, I'll be honest. Can I swear something? Thank you.
What?
So this is the question, okay? So this is to do with week 8, I think. It's to do with... It's regression analysis. Here it is. Regression analysis.
I just started coding.
Shh, 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 shh. Wake him up. Wake him up. Okay. So what I'm gonna do in this question, I'm gonna show you guys a bunch of MATLAB code. Yeah, I know. Honestly, I didn't memorize it last year. I got it wrong.
You didn't memorize it.
I got it wrong. Like,
How much did you score?
here it is. So, what I've done first. Hey, sorry. My iPad needs charge, but so what I've done, I've made two sets of arrays, right, or columns. I don't know what they're called. Arrays. One for weight, one for height. Shh. Hey. Oh no, fuck. Anyways, so what we need to do here is we need to find the linear regression line. So to find beta 0 and beta 1. So to do that, we're going to use MATLAB. Okay? There's a certain function or a certain code that you can use called fit LM. So fit LM means fit linear regression model. That's literally what it means. I read on it. That's what it means, right? So fit LM, you're going to do your weight versus your height. So your x versus your y. So it's going to be fit LM x, y. So your x-axis, then your y-axis, okay? And what you end up with is this huge thing on the right, okay? Cindy, listen. So, take a look. This is what we get when you do the fit LM, okay? Are you sure?
Yes.
So, what are these two values mean, Cindy? So pretty much, when I go back to my thing, it's a linear regression line. So y equals to mx plus b, or in this case, we have an intercept, and we have a gradient. Okay, so if I go back here, our intercept is given by 53.733, and our gradient x1. So this is beta 0, and this is going to be beta 0 and beta 1. Okay. So here it is. So I've got beta 0, beta 1, and the SE stands for our standard error. Okay. Standard error we'll need later on. I'll show you. But yeah. A few other key values that we need is root squared. Root squared. What's R squared? R squared. Coefficient of correlation coefficient, whatever it is, squared. Right? So we're going to have to square root it to find R. Right? Which is actually one of the questions. Right? So one of the questions that ask us, what is the sample correlation coefficient? Right? That's just going to be R squared. Square root of R squared. Whatever, yeah? Proportion of variability, I don't know. I'll be honest, I left it blank. Because I don't know. Does anyone know? Is it R squared? I forgot. I thought it was going to be P. It might be the value of P here. No, that's not. That's a great idea, actually. What does ChatGPT say? Does anyone know? Oh, Cindy might know. Cindy? You might know. What's the proportion of variability? Right now you're teaching me as well. Okay, where is it on the table?
It is all square.
Is that square?
It is all square.
See, I actually wrote that down earlier, but I just had to rub it out. So r squared is equal to 0.944. Okay. So I'm learning with you guys at the moment. So our coefficient of I forgot what it's called. Proportional variability is given by r squared. Our correlation coefficient is given by just r. Okay. Any questions about that? Yeah? No? So, what? Are you leaving? Anyways, so yeah, the reason I wanted to show you this table is just to look at the key values. So beta 0, beta 1, proportional variability, we know that now. And then when you square root that, you get your correlation coefficient. Okay, when you get to hypothesis testing, you're going to need this side of the table as well. Okay, hypothesis testing, you need this side of the table. So, see this stuff? This is all like your hypothesis tests. Alright? So the orange stuff is your test statistic, which when I go back here, this is your test statistic value. So MATLAB does it for you. Instead of doing it by hand, like I showed you here, use this. Okay? Similarly, your p-value is your yellow stuff. Right? This, they also give it to you on the table. On the right. Okay? What the You're not rejected. Okay. Might have been an important call. Oh well. There's also something called a rejection region, which they might ask you in some other question. I'm not going to cover it now. Anyways, let's move on. So part B, use the result in part A, so this thing here, to estimate the height in inches of a person who weighs 100 pounds. Okay? So we know that height is equal to beta 0, which is what is beta 0? 53.733 plus 0.00084361 times x. So the x here, this is our weight. Okay? So we're going to sub in 100 to that to get our height. At the back, stop fighting. Okay? So take a look here. So we have a height, and I'm going to let x equal to 100. Why is he staring at me? Not you. Anyways, when you sub in, you get 55.58 inches. Keta knows a lot about 55 inches. How about Wilson? Are you watching Wilson? Anyways. Okay. I hear now. Yeah, it does. I did times 10. Fuck. That looks much better. Much more recognizable. Okay. No worries, man. Okay, let's take a look at part C. Part C is asking us to find the confidence interval. So confidence interval, there's like two types of intervals that we're going to look at for regression analysis. There's something called a confidence interval and something called a prediction. Okay? So confidence interval, I'll show you the code for it. Oh, you can do it by hand. Good luck. But I'll also show you the code. So here it is. So this is the confidence interval. I think this might be for 95%. Not for 97.5. How do you make it into 97.5%? I forgot. 0.0.75. Is it? It's about 0.99. Something like that. Yeah, sorry? 985. Yeah, that's what you're using. 985? 9875. Yeah. Yeah, because alpha is equal to
Is that right? 97.5. And then it will be 2.5. And then half the
Sorry guys, one sec. 97. That's what the confidence interval is.
Wait, is it asking for 97.5 or
97.
Oh, then it will be 1.5.
So alpha is equal to 1.5. So it'll be oh snap. Okay. I don't know how to put it, I'll be honest.
Are you posting this file?
Yeah, I'll post it.
That folder?
Yeah. So you see this stuff? I think this is for a confidence interval 95%.
Thank you.
No worries. The fuck? I don't know about 97.5. But anyways, this is the code for it. You're gonna use predict. Right? So what we have here is mu hat. So that's our mean, and CI stands for our confidence interval. What you see over here, they give us a mu hat value, and they also give us a confidence interval over here. Everyone see that? That's going to be our confidence interval. For the next question, they tell us to find a prediction interval. In MATLAB, there's a separate code for that. In MATLAB, we're going to use this one. So it's the same thing at the start, but you're going to add prediction and observation at the end. Okay? So that's straight from the stats lectures, week 9, I think, week 10. I think it's under assumption, new assumption, something like that. It is. I checked it this morning. Yeah, and you get a new value. Okay. And yeah. I'll be honest, I kind of see this. Okay. I don't quite remember this stuff, but I'll try to go through it. So H0 stands for, like, we're looking for a hypothesis test for beta 0. Beta 0. This one will be beta 1. I think it should be equal to 0. This, I don't know. It should be equal to 0. No, they can't be the same. So not equal to equal with the slash. Yeah, that makes sense. And the observed test statistic, we're going to go back to our fit-LM graph here, and we're going to take these values on the right. So for our intercept, what the hell is that value? 2.9. Oh. We take it for. It's one of these ones. But I think the 3 decimal places. Cards, I don't know. Okay, this stuff I think I covered it last year. Wait, one second. I haven't touched 2002 since last year, term 2. Forgive me. Test statistic, here it is. And the p-value you can also get on your... You can do it by hand, or you can do it using MATLAB. Yeah, okay. I'm actually not too sure how to do part F. There should be solutions online though. Or if I do figure it out, I'll put the solutions with it. Okay, if I do figure it out. If I don't, unlucky. Right. Oh wait, I'm not even showing you my screen. Yeah. So yeah. Part F is, oh yeah, I forgot to go through part E. So if the weight of a person increased by 4 pounds, how much would the expected change in height be as well? So the weight we know is x. So to find the change in weight, you can just let x equal to 4, right? So let x equal to 4, and you get a change in height to be some value. Let me sub it in. Yeah. So the exact same thing we did earlier. So it should be 54. No. When you do a change in height. Oh, okay. You know what? I'll actually explain this one. Sorry. So if you think about it, a change in height is going to be beta 0 plus beta 1 x1 minus beta 0 plus beta 1 x2. So the beta zeros cancel out. So you're left with beta 1 and you're changing x. Changing x is just going to be 4. Okay? So it's going to be beta 1 times 4. 0.3337. Yeah, I did it in my head. Tashi. Okay. Because of time, we'll probably end it there. Alright. If you have any questions, you can come up to the front. I'll try my best to answer it. If not, I'll end the recording there as well. Thank you for watching, and thank you guys for coming as well.